so we are going to discuss about linked list implementation. So in linked list, what is what is a linked list means? We will store data and link to the next data in one node. Okay, here we will refer it as a node. A node means a node may contain data and link the address of the next node's address. Okay, next node's address we will store together. Data and address will be there. This is called one single node. Okay, so like that we will create n number of nodes and store each node's address in its previous node. Okay, so here we will follow two data structures. So what are the two data structures means? Head structure and data node structure. What is the purpose of head structure means? The head structure contains the address of the first node. Okay, if you have a list of 10 students, the first student's address that will be stored in the head structure, and also the number of students, metadata. Okay, what is the metadata means? Data about data. So if the linked list contains 10 student details, the number of students, so that can be stored in count. Not only these two, if you wish, you can add and store more details in the head structure. What is the address of the last student? Okay, and what is the maximum mark student? Like that, some important informations we can store it in the head structure. Then data node structure. Data node structure also we discussed in the last class. After that, we discussed about what are the 10 basic algorithms or operations that we use to perform in any list. Okay, create list, insert node, delete node, list, retrieve. These are some of the basic operations that we used to perform in any list. Okay, and in this last session we discussed about three operations we discussed. That is creating a list, inserting value into the list, and displaying the entire list. These three we discussed in our previous session. Okay, for that algorithms also we discussed. Now in the PPT, in the respective algorithm, after that I have included the C implementation also. See here, this is create list and the respective algorithm, respective C implementation. Then insertion and respective algorithm, and also its equivalent C code. The algorithm is directly converted into the C code. This we discussed. Sorry, this also we already completed. The one more thing is we didn't discuss the demo for the insertion and display. Okay, that we will see first. Then we will move to the next algorithm. Okay, first we will see the C implementation for the insertion and display operations. Okay. Okay, so this code is a create list we discussed in our previous class. Okay, so for create list we are passing the list structure. Okay, this is what list structure, and that reference we are passing, and we are allocating the memory. Okay, once the memory is allocated, then if any memory allocation error is there, then we are returning 0. Otherwise we are returning 1. 0 means false, 1 means true. Okay, if the memory allocated is successfully for the list, then it will return 1. Okay, and from main we are calling it. Okay, so list creation, in case if there is any error, list creation error, otherwise list creation success. So this is what we discussed in previous session. Okay, so list creation success, this is over. So this program is list operation 2. Okay, now I have taken the same program and added the insert functionality and display functionality in the next program. Okay, so the next program is the list operation 3. Here also the create list is same. In that I have included insert operation and also the display operation. Okay, and two more operations. Today's operations, search and delete, we are going to discuss that also included here. Okay, let us first discuss about the insert operation. Okay, see here, insert operation, I am passing the list. Okay, in which list we need to insert and what is the data we need to insert. Two parameters I am passing, and this function returns the integer. If you are checking the algorithm, okay, if you are checking the algorithm, see here, the algorithm takes a list and the data to be inserted. Okay, if you are checking, I have modified the algorithm little bit. Whatever the algorithms given in the book, okay, that algorithms I have modified a little bit according to the C implementation. You can write the same algorithm given in the book, and also you can follow the algorithm given by me, no issues. Or you can write your own algorithm also. It should follow the correct logic. That is what important. Okay, because algorithm will differ person to person. Only thing is whether at the end it gives produces correct result or not. That is what important. Okay. Now in insert algorithm, first we are allocating memory for the new node. Then for the new node we are assigning the data, and the new nodes next we are assigning the head address, whatever the address we stored in head, that we are storing it in next. Then the head address will point to the new node. Okay, so see here, suppose if you want to store 39, insert beginning we are discussing. See here, suppose if 39 I want to insert means first memory allocated for 39. Now whatever this head address pointing to means whatever the address stored in head, 75 address is stored in head. So this 75 address we need to store it in 39. Then in head we need to store the address of 39. See here, now head will point to 39 and 39 will point to 75. So 39 is stored in the beginning of the list. Okay, inserting in the beginning or inserting in the empty list, both logic is more or less same. Okay, you can check the pseudocode given in the PPT. Insert in the empty list, insert in the beginning, both are same logic. Now see here what we are doing, we are allocating the memory for the new node. Okay, now for if the memory is not allocated, it will return null. Suppose if memory allocation error, we are returning 0. Otherwise in new node data, whatever we are receiving as a parameter, that we are storing. Then new node next equal to list1 head. See here, new node, this new nodes next this place. Okay, the 39's next address. Okay, here what we need to store means whatever the address we are storing it in the list head. That is what we are doing it here. New nodes next is list1's head, and then list1 head equal to new node. In the head of list1 we need to store the 39 address. Okay, so that is what this line is doing. In list1's head we need to store address of new node, and after that count we need to increment L1 count plus plus return 1. Okay, so this is insertion. Insertion is over. Now let us come to the display. Okay, so display is very simple. First we need to store the head address. In head, whatever the address is there, that we need to store in a temporary pointer, and until it reaches the last node. How we can identify the last node? The last nodes next will be null. Okay, so walker not equal to null until walker becomes null. Printf walker data walker equal to walker next. Okay, this is like a simple for loop only. First time walker will be pointing to head. Sorry, the whatever the address is stored in head, there is 39's address stored in walker. Okay, so walker will point to 39. Okay, and it will print 39. Next time walker equal to walker next. Walker next means in 39's next what is available? 75, the address of 75. So now walker will point to 75, and it will print 75. Okay, after that walker equal to walker next. 75's next is what? Null. So walker will become null. So when the walker becomes null, the loop will be terminated. Let us check it. See here, first insert operation 1. I'm inserting 100, value inserted successfully. Then again 1, I'm inserting 200, value inserted successfully. Okay, and again 1, I'm inserting 300, value inserted successfully. Now second operation. What is second operation? Display list. See here, 300, 200, and 100. So insert operation and display operation is working fine. Okay, that is what we discussed in our previous session. Okay, insert, beginning, and display. Now in today's session we will discuss about the search operation and then delete operation. Okay, first we need to discuss about the search operation. Why means if you want to retrieve a node, if you want to get any node, if you want to update any node, or if you want to delete any node, first we need to perform the search. Okay, so we should know the location. Suppose if you are searching a target value, okay, whether it exists in the list or not. If it exists, what is its address, and also its predecessor node's address we should get. Okay, why we need the predecessor node's address we will discuss now, or discuss later. Okay, so whether suppose in a list 100, 200, 300, 400, 500 is there, if we are looking for 300, whether the 300 exists in the list. Okay, if it exists, what is the address of 300? Okay, and also what is its predecessor node 200, and what is its address? Okay, these two details we need. Suppose if you want to delete any data, okay, suppose if you want to update means only the target address we need. Okay, and you want to retrieve also only the target 300's address we need. So the searching operation is very, very important. Okay, Here, list search. A list search is used by several algorithms to locate a data in a list. Okay, to insert a data after a specific location. Suppose if it is ordered list and we need to order, we need to insert a value means after which node we need to insert. For that also we need to perform the searching, and deleting also we need to perform searching. Okay, update also we need to searching, and its predecessor node we need. Okay, so all these things operations we need search. That's why next we are going to discuss about search. Okay. And here it is possible to use only sequential search. Okay, it is not possible to use binary search. Why means here whatever the data we are having, it is independent of each other. Okay, we need to perform the sequential search here. Okay, and the sequential search returns the location of an element. So here also we need to return the location of the element. So if you are taking the diagram given here, okay, the head address pointing to the first node is 3. 3's next is 10. 10's next is 2. 2's next is 1. 1's next is null. Okay, so 4 elements are there. Suppose if we need to search for target 2, okay, then what we need to do means we need to perform a search operation. So create a walker temporary variable, and initially walker will be point to the heads, whatever head is pointing. So initially walker will point to 3. Okay, 3 is not equal to target. So walker equal to walker next. So walker next is 10. Now walker will be pointing to 10, and walker data is 10. It is not equal to 2. So again walker equal to walker next. That is next data. Now walker will be pointing to 2. Okay, and walker data and target, whatever we need, both are same. So here the target data found. So what we need to do means we need to store the address of this 2 in one variable data out. Okay, and also we will store the predecessor node's address, that is 10's address. Okay, suppose if you are going to perform delete operation, the predecessor node's address is important. So in the search form we are storing the current node's address. If the data found, that is the current node and its address, and also predecessor node's address, 2 we are storing. Okay, and we will perform this search till the last node of the list. Suppose the walker becomes null and its data is not equal to target, means the data not found. So this is what the process. Let us check the algorithm now. See here, algorithm. What are the things we are passing? A list and the target to be searched, and a p location of the element we are looking, and a p predecessor, the predecessor node's location. Okay, and search list passes back the address of the node containing target. Okay, and it's a logical predecessor. These two values we are returning from this search algorithm. Okay, and also we are returning true or false. If the data found, we are returning true, otherwise we are returning false. So initially the predecessor node's address is we are setting to null. Okay, and then location equal to list head. See here, location will be pointing to list head. Okay, list head is pointing to 3, so p location also will point to 3. Now loop until p location not equal to null and the target not equal to location. Okay, target not equal to location's key, location data. Okay, until these conditions satisfies, we need to set predecessor node equal to p location and p location equal to p location next. So at the first iteration of this loop, the predecessor node will point to 3 and the location will point to 10. Okay, in the first iteration. Now second iteration, the predecessor node will point to 10 and location will point to 2. Okay, that's it. Since the target is 2, now the loop will terminate. Okay, after loop terminates, what we are checking, see here, if p location is not equal to null, yes, p location not equal to null, it is pointing to 2, and the p location data equal to target. If target data and location data, if both are equal, found equal to true. Okay, we are setting one variable called found and we are assigning true to found, else found equal to false. Return found. So at the end we are returning true or false. Okay, at the end we are returning true or false. Okay, so this is what search list algorithm. Okay, let us check the implementation. C implementation. See here. For search node, we are passing struct list 1, then target and then location. We need to return this location, and the predecessor node. We need to return the predecessor node also. Okay, these 4 parameters we are passing. Integer found equal to 0 initially. Okay, then predecessor node's address initially null, location address it is initially its address, while location not equal to null and the data not equal to target. Predecessor node equal to location and the location equal to location next. If location not equal to null and the data not equal to target, means found equal to 1, else found equal to 0, return found. So we are calling the search operation from here. Okay, enter a value to search, and the data we are passing. And if it returns one such success, we are printing the data. Otherwise, we are printing the data not found. Okay, let us take it. See here. Now insert operation 100. Okay. Now 2 10. Sorry. 2 10. Then 2. Sorry. Again insert 1. 10 I am inserting. 20 I am inserting. Then again 1. 40 I am inserting. Again 1. 80 I am inserting. Now displaying the list. Okay. Now the list contains 80, 40, 20, and 100. Okay. Since it is insert beginning, we are discussing about only one type of insertion, insert beginning. Insert middle, end, we have not discussed so far. Okay. Now insert beginning. Since every element we are inserting in the beginning, so it will be inserted in the beginning. Okay. 80, 40, 20, and 100. 4 elements are there. Now let us go to the search list 3. Okay. I am searching for 40. Okay. 30 success, 40 exists. Okay. Now again one more search. I am searching for 100. The last element I am searching, it is giving correct result. Again, first element I am searching. First element is 80. 80 also available. Okay. 80 I searched, 40 I searched, 100 also I searched. Then if you wish, you can search for 20 also. 20 also success. Suppose if you are giving any element which is not in the list, it should give proper error message. See here. Now I am giving 200. 200 is not there in the list. It is giving error. 200 not found in the list. Okay. So this is what search process. Okay. This is what search process. Okay. Now let us exit. Okay. Create, insert, search. 3 algorithms we discussed so far. Okay. 3 algorithms we discussed so far. Next, we will discuss about a delete operation. Okay. In delete operation, what we need to do means here only the predecessor node's address is very important. Okay. So the delete node algorithm logically removes a node from the list. Okay. By changing some of the links, its predecessor link should point to the current node's next link. Okay. The pointer alteration we need to do. Yes.
So what was the need of that predecessor node? I mean, in that previous program. Sir?
Yes. Wait. Actually, the predecessor node we will use it while performing the delete operation. Okay. Actually, what is the purpose of functions, sir?
Yes, sir.
What is the purpose of functions? Why we are writing functions?
So to minimize the program, sir.
Yes. So the previous code is a search operation. Correct. In delete also we will perform search. We have to search the respective data whether it exists or not. So what we are going to do means from this delete functionality we are going to call the search functionality. Okay. For delete operation only the predecessor required. Okay. In search actually we are not going to use predecessor. Okay. So now you can understand here. See here in
Yes,
delete
sir,
operation predecessor we need. Okay. So from this algorithm we will call that algorithm. I'll give both versions, the one which calls the search and the delete algorithm which directly deletes the node. Okay, both we will see. First we will see this algorithm. Okay, so to logically delete a node, we must first locate the node. Okay, and also we should know the predecessor node's address. Okay, we need the target node's address and also its predecessor's address. 2 we need. Okay, now let us check these 2 diagrams before delete. So what we need to delete means is 75. Okay. And 75 is the next, contains 134. Now, what is the predecessor of 75? 39. Okay. If you want to delete 75, what we need to do means the 39 should point to 134. Instead of pointing to 75, the 39 should point to 134. Okay. Then we need to delete the since we are using the dynamic memory allocation, this memory must be deleted by us. We have to call a free function to delete this memory. Okay, so that is what we need to do. Okay, 75's next contains 134 and 39's next contains 75. Now 39's next should point to 134. That is, we should give a statement 39 next equal to 75's next. That's it. That is, predecessor nodes next equal to p locations next and delete p location. That's it. P location recycled. Now 39 is pointing to 134. We deleted the 75. Let us check the algorithm. See here, algorithm delete node. We are passing list, predecessor, location, and data out. Okay, what is the data? We need to delete it. Okay, so actually it is not here. I need to make small correction. This is target, and then not data out. Okay, now see here, algorithm, we are passing 4 parameters: list, target, predecessor node, and location node. Okay, and at the end of this algorithm, the data will be deleted if it exists. Okay, and this also returns true or false. Okay, see here, if search node. What is the search node? This is the previous algorithm. Okay, the previous algorithm we are calling. If it is true, the element exists, then the predecessor node's address will be stored in pre, and the element which we need to delete it, that address will be stored in P location. Okay. Now, if it not exist, we are returning false. Okay. If search returns false, means we are returning false. Otherwise, the P location will contain the current node, and the P predecessor will contain the predecessor node's address. Now, if list head is P location, okay. If the list means the P location contains the address of element to be deleted. Okay. See here, in the there are 2 cases in the deleter. Okay, deleting the first node and deleting the rest of the node. Okay, see here, if the head contains the element to be deleted, if 39 is the element to be deleted, okay, then the P location will point to 39, and the head also will point to 39. What is the meaning? P location and that head contains the same address, means that is the first node's address. Suppose if we are going to delete first node's address, okay, after deleting 39, the 75's address we need to store in head. Okay, head should point to the 75. Okay, that change also we need to do it. That is what deleting the first node. If middle node means this example illustrates, this figure illustrates the deleting any node in the middle. Now see here in the algorithm, if list head is a P location, it is the first node. So list head should point to the P locations next. That is 39's next is 75. So 75's address must be stored in head. Otherwise, it is in the middle. So the predecessors next is the locations next. Okay, predecessor next is the locations next. That's it. Only one pointer change. End if recycle. The memory is recollected. Now let us check the implementation. See here, the delete node. Okay, so delete node, list we are passing, target we are passing, location, and the predecessor node. Okay, so we are calling the search. Okay, the search node we are calling. For search node, L1 target, location, and the predecessor node we are passing. So if the element found, the location contains the element to be deleted, and the predecessor contains the predecessor node of the element to be deleted. That will be stored in the P predecessor. Okay. Suppose if the search node returns 0, we are returning 0, the element not found. Otherwise, see here, P location equal to L1 head. If L1 head and the P location both are same, then the element to be deleted is the first node. We need to store L1 head equal to P locations next. Otherwise, predecessor nodes next equal to locations next. See here, the predecessor nodes next, 39's next is P locations next, 75's next. What is 75's next? 134. So 134's address will be stored in 39's next. So 39 will directly point to 134 now. Okay, so the P location is free now. We need to deallocate the memory. Okay, we need to deallocate the memory. Free P location. That's it. Okay, now let us check this program. Okay, 1 insert. I'm inserting 10, 20, 30, 40, 50. Totally 5 elements I have inserted. See here, 50, 40, 30, 20, and 10. 5 elements inserted. Okay, now I am going to delete a value. Okay, so let us delete the last element once. Okay, that is 10. We will delete it. 1. Sorry, delete operation is 4, and the element to be deleted is 10. Delete success. Now let us display the result. Okay, that is 2. See here, 10 is removed. Okay, now let us delete the first element, okay, or any of the middle element. Let us delete 30 now, okay, 30. Okay, delete success, 30 deleted. Okay, now let us display the list. See, 50, 40, and 20. Let us delete the first node. Okay, 4 and 50. I'm going to delete. Delete success, 50 deleted. Now let us display it 40. We will delete all the elements. Suppose means let us give some elements which is not in the list. Okay, 4, and I'm going to delete 100. See, error 100 not found in the list. Okay, and let us delete all the elements. 4, 40 deleted, and 420 delete success. Now suppose if I'm displaying means nothing will be displayed. Okay, nothing will be, no element in the list. Okay, it is not displaying. So this is what list delete operation. Okay, this is what list delete operation. So in this example program, I have given create list, insert at the beginning. Okay, this is insert beginning, and the search node, and this is delete node. Okay, so 5 algorithms we have created here in this example program: create, insert, search, delete, and display. Totally 5 algorithms we discussed in this example program. Okay, I'll share this. I'll post this code now in the classroom. Okay, I hope all of you have systems with you. Please try to execute this program and check it. Okay, I'll give some 10 minutes time. Okay, whoever having system now, please try to execute this system, and if you have any doubt, please post it in the chat window. Okay, this is very, very important. If you're not understanding this program, means whatever the programs we are going to discuss in the further classes, it is difficult to understand. Okay, and it's equivalent to CPP implementation. I will upload it in the before the next class. Okay, this is C implementation. Okay, I'll upload this program in classroom now. Those who have system now, please try to execute it and get back in case if you have any doubt. Okay, next 10 minutes, no more classes. All of you try to execute it and come back.